All right, so this time we want to look at some ways to apply these similarity problems. So let's take a look here. Proportions. This is some examples of proportion problems that you might have. So if 3 bottles of water cost $3.17, how much would 10 bottles cost at the same price? So we could say, well, 3 bottles at $3.17 equals 10 bottles at how much? You could set up a little proportion like that. And then cross multiply. 3x equals 10 times 3.17, so that'd be 31.7. Divide by 3, and x equals that. So 31.7 divided by 3, and that is 10.56. So 10 bottles would cost $10.56. All right, this one, it says Max takes 1,329 minutes to run half of a mile. That's pretty slow. I don't know if I left out a decimal when I copied this over, but to run half a mile, so 1329 minutes for every 0.5 miles. How long? So x, how long would it take him to run 27 miles? Cross multiply. 1/2 x equals 27 times 1329. That's 35,883. We'll divide that by 1/2. And that's going to be 71,766. Divide that by 60 just to convert minutes to hours. That's 1,196 approximately hours. So that's a really long time. Max is not going to make the track team. All right, on a map, scale drawings. On a map, you see at the bottom of a map, it has a little scale, like to show how big or how small the map is compared to real life. So the scale of the map is 1 inches equals 150 miles. If 2 cities are 2.5 inches away on the map, how actual miles would they be apart? Okay, so we're going to say that 2.5 times 150, cross multiply, and that is 375 equals 1 times x, so that's just x. So they would be 375 miles apart. Okay, Orlando and Tampa are 85 miles apart. How far apart would they be on a map with a scale of 0.5 centimeters to 15 miles? So every 1/2 of a centimeter equals 15 miles. And how far apart on the map are they? So that's the centimeters. And 85 miles. When you're doing the proportions, you want to make sure your units of measures line up, right? That's how you know you've got things in the right place. So 0.5 times 85, cross multiply, is 42.5 equals 15x. Divide that by 15, and x equals 2.83. So they would be 2.83 centimeters apart. Okay, so these problems were set up where you're looking at a mirror on the ground, there's a tree, there's another mirror on the ground. So basically what you're creating is two similar triangles, because you have this is congruent to this, and then they're each making a right angle with the ground. Okay, so when you see a setup like this, we're just going to use proportions. Because they're similar, we know they're proportional, so that means we can solve for things in these problems. So here we go. We've got a flagpole out front. They want to figure out how tall is the flagpole, so we're going to be person looking at a mirror, and we want to know this. Okay, so I can actually set it, you can set up the proportion a couple different ways. I can say I can match 5. It doesn't really matter as long as the matching parts match. So 5, the height, 5 and X match, and 12 and 48 match. It would also be correct if you matched up in this way. If you said 5 to X equals 12 to 48. That would be the same, because watch, when you cross multiply, you're going to get 12x equals 5 times 48, whatever that is, 240. Okay, when I cross multiply this, I'm going to get 12x equals 240. So as long as the proportional things are matched up, it's going to be okay. All right, finish this off. Divide by 12, and x equals 20. So the flagpole would be 20 feet tall. All right, the Eiffel Tower is 1,063 feet tall and is 9,000 feet from the mirror. On the floor, the person standing is 15 feet from the mirror. How tall is the person? Okay, same idea. Draw it out if you need to. And again, you can say x to 15. So height to distance from mirror equals height to distance from mirror. That will work. So that means I have 9,000x equals 15 times 1063. And that is 15,945. Divide by 9,000. And I get 1.77. That's a very short person if he's 1.77 feet tall. All right, the same ideas with the shadows sort of problems. We've got this. The idea is that the sun shining down would make the same shadow. So we've got this angle here would be the same, and the angle that the sun is making would be the same. So either one of these. Okay, so we're going to have similar triangles there. Okay, so again, if you don't have a picture, let's see, I don't have a picture there, so let's set this up. We've got a 5-foot tall woman, cast a 7-foot shadow, and then a nearby tree, cast a 20-foot shadow. How tall is the tree? All right, so 5 to 7 equals x to 20. Height to shadow equals height to shadow, or and 14.28 is how tall the tree is. Okay. Here's another example. Maybe pause this and see if you can do it. The building is 230 feet and it casts a 420-foot shadow. Lamppost cast a 14-foot shadow. How tall is the lamppost? So height over shadow equals height over shadow. Cross multiply. Solve for x. And the lamppost is about 7.5 feet tall. All right, that's it. Have a great day. Bye-bye.